So right around we saw this chart where kind of the AI progress kind of went vertical. Right around that time, we saw a lot more tweets from AI industry insiders saying that superintelligence might be a lot closer than we first realized. Now, of course, this is just showing kind of the scores on the ARC AGI. That's just one of the benchmarks. But I think this is kind of representative of what we're seeing with AI progress right now. We kind of have this slow improvements, etc. And then somewhere right around here, it goes vertical. This jump is from sort of the kind of GPT-4 class models to reasoners. So the models that are able to kind of think behind the scenes, think about the answer a little bit, and then, use that kind of data to answer the question. Here's Jason Wei, AI researcher at OpenAI, posted this recently. Magic is what happens when an unstoppable reinforcement learning optimization algorithm powered by sufficient compute meets an unhackable reinforcement learning environment. Now, we'll unpack what that means in just a second, but just a few more examples. Sam Altman, of course, talking about the fact that we might be nearing the singularity, kind of that sort of rapid takeoff. Also mentioning that the O3 Mini will outperform O1 at a massive cost reduction. O1 was this revolutionary model that kind of like scared a lot of people. The O3 is, it's not released yet, but it supposedly takes it to a whole nother level. It unofficially beat the ARC AGI sort of human baseline. Kind of a big deal, but the O3 Mini is going to be better than the O1. So the thing that was like revolutionary 3, 4, 5 months ago, the new thing that comes out, several months later is like smaller, faster, cheaper, but also much smarter. And you've probably heard that Sam Altman is kind of talking about shrinking timelines. So he's saying that all the stuff, AGI, SI, is going to be closer and closer. He's also kind of like revising upwards what those things will mean, saying that they're going to be kind of bigger and more important and have more abilities than we first realized. The point here is everyone's abuzz talking about how something big is just around the corner. What is this thing that got everybody excited? Well, let's take a look at this post on lesswrong.com, specifically a comment made by Gwern. So he's somebody that's kind of a thought leader in the space. Here he is on the Dwarkesh Patel podcast. That's not actually him. It's not his voice. It's like an avatar to protect his anonymity. So he doesn't want his face out there, his voice out there, but he's somebody that's kind of like well-known and well-respected in the field. And let's briefly take about what he's saying here because it's capturing a lot of people's attention online, on Twitter, X, etc. We've talked about some of this in the past, the idea that certain models act like teacher models. We've talked about this before, the fact that certain models, they act like teacher models, creating smaller sort of student models. That's also referred to as knowledge distillation. And we saw, for example, the open source Chinese model DeepSeek, the V3, for example, is very good. It's not a reasoning model, but the model that came before DeepSeek R1 was a reasoning model. And as they talk about in the DeepSeek V3 paper, they're saying that they've used sort of knowledge distillation from the previous model to create the V3. So this is kind of a crucial thing to understand about what's happening here, why everyone's thinking that everything's going to start happening much faster and much sooner than we first anticipated, and why some of the charts and the benchmarks, why that kind of a line of progress is going vertical. So Gwern is saying, I think this is missing a major piece of the self-play scaling paradigm. Much of the point of a model like the O1, so that's the first sort of reasoner model, the point of it is not to deploy it, like it's not to give it to us for us to use, but to generate training data for the next model. I've always used kind of the hive queen analogy, right? So it's there to like lay eggs and create drones. It's not going out there and doing stuff itself, right? So every problem that the O1 solves is now a training data point for the O3. Or specifically, he's sort of kind of referring to them as N01 and N03. So as in any model that's created is made to be a solution for some stuff for the next model, the next generation model. Any O1 session which finally stumbles into the right answer can be refined to drop the dead ends and produce a clean transcript to train a more refined intuition. So these chains of thought that lead to the correct answers get used as training data for future models, right? So that model is able to kind of like recursively improve itself, bootstrap itself to superintelligence, as that Stanford paper said, right? The self-taught. So if you recall this paper from 2022, right? May 2022, a long, long time ago in the AI era, sort of star self-taught reasoner, bootstrapping reasoning with reasoning. out of Google Research and Stanford. I mean, they pretty much say here that it's possible for it to bootstrap itself into higher and higher levels of intelligence, potentially going beyond human level intelligence. Literally, here's like the secret sauce. Like this was out, some time ago, 3 years ago. So Gwern continues, this means that the scaling paradigm here may wind up looking a lot more like the current train time paradigm. Lots of big data centers laboring to train a final frontier model of the highest intelligence, which will usually be used in a low search way and be turned into smaller, cheaper models for the use cases where low/no search is still overkill. So how I am interpreting that is like if you look at the DeepSeek V3, right? So it's going head to head against things like Claude 3.6, GPT-4o. And this is a good apples to apples comparison in that these are both non-reasoning models. So GPT-4o doesn't have a hidden chain of thought where it's thinking about the answer. You ask it a question, it immediately spits out the answer. It doesn't take some time to think about it. And that's what all of these have in common. But notice this in blue is DeepSeek V3. So notice how insanely much better it is at things like the AIME, the super high level, sort of like the math problems, right? It's basically sitting at just about 40% accuracy. The rest of them, like the highest one is 23. GPT-4o is 9. What's this special secret sauce that allowed it to be that much better? It's not necessarily a bigger model. It was 10 times less expensive to train than, for example, the Llama model, the equivalent Llama model, because they found a way of training it that's much more efficient, that's much cheaper. Here's another chart of the V3. So this sort of blue shaded line, as you can see, it's just head and shoulders above everything else. What's their super secret special sauce? Well, I don't know, but maybe it's this. So post-training, once they train this model, they do knowledge distillation from DeepSeek R1. So again, R1 is the DeepSeek's answer to the O1. So DeepSeek R1 is the equivalent of OpenAI's O1, or at least it's supposedly equivalent. It's sort of supposed to be the reasoner model from DeepSeek, right? And so they're saying we introduce an innovative technology to distill reasoning capabilities from the long chain of thought, COT, model, the R1, specifically from one of the DeepSeek R1 series models, into standard LLMs, particularly this one, DeepSeek V3. Our pipeline elegantly incorporates the verification and reflection patterns of R1 into DeepSeek V3 and notably improves its reasoning performance. So again, you have the reasoning model, the thing that's able to produce great outputs but can be kind of expensive to run, right? Because you might have to run it for longer periods of time for it to really think through everything. So this is the R1 from DeepSeek, this is the O1 from OpenAI, etc. And this is the teacher model. This is the reasoning model. This is the sort of the original model. It outputs its reasoning, its thoughts, if you will, right? So it's reasoning, its thoughts. In the original STAR paper, they referred to it as the rationales, right? So the thinking behind the answer, like whatever you want to call it, rationale, generalization, etc., whatever you want to call it, right? So it creates that. Rationale, thoughts, reasoning, whatever. That is then used as training data or post-training data, this knowledge distillation. That's another word for it, right? Knowledge distillation. It's used as synthetic data for the next generation of models. In the case of the R1, that's the V3. V3, my head is in the way, I apologize. So the next generation of model is being trained by sort of the thoughts, the reasoning, the knowledge distillation from the previous model. So we humans, we created version 1. Then version 1 is used to create version 2, the new and improved model, right? And of course, this is, we're done, right? This is where progress stops and we don't have to do anything else, right? No, this is where stuff gets nutty because version 2 creates version 3. Version 3, whatever, it goes on to infinity potentially, unless we find something that sort of stops this sort of progress in its tracks, this thing goes on for infinity. But here where he's talking about like creating smaller, cheaper models for use cases where low or no search is still overkill, he's more talking about something like the V3, right? So we're able to create this faster, cheaper, smaller model for specific use cases. That's the same thing that Sam Altman was talking about with the O3 Mini being better than the O1, even though it's faster, cheaper, easier to use, etc. The big smart teacher models can create smaller models for specific use cases, right? And you might have, you can create a million different ones, each for their own little special thing that they're genius at. So in other words, you don't pull out the big queen model for every single use case and task that you want it to complete. It's much more likely if you have a specific task in mind that this thing, the super mega smart model, creates a little spin-off that's, cheap, fast, smart, that does that one particular thing that you want to do really, really, really well. So Gwern continues, inside those big data centers, the workload may be almost entirely search related, as the actual fine-tuning is so cheap and easy compared to the rollouts. So in other words, kind of the fine-tuning of the next generation model is easy, so most of the time is going into generating these knowledge distillation or rationales or chain of thoughts, whatever you want to call it, aka search. And as he continues, as before, what you see is basically high-end GPUs and megawatts of electricity go in. You wait for 3 to 6 months, and a smarter AI comes rolling out. I'm actually mildly surprised OpenAI has bothered to deploy O1 Pro at all, instead of keeping it private and investing the compute into more bootstrapping of the O3 training, etc. This is true, and also, they do not allow us to see the chain of thought thinking behind the scenes. We don't get access to that. We don't get to see it. That means we don't get to do our own sort of knowledge distillation from it. We don't get to take those thoughts and build our own models, etc. So in my Hive Queen example, we get to have the queen do some work for us, but we don't get it doesn't lay the eggs that we can use, so to speak. This analogy breaks down somewhere, but you get the point, I think. But he's saying this is apparently what happened with Anthropic and Claude 3.6 opens. It didn't fail, they just chose to keep it private and distill it down into a small, cheap, but strangely smart Claude 3.6 sonnet. If you're wondering why OpenAIers are suddenly weirdly, almost euphorically optimistic on Twitter, watching the improvement from the original 4.0 model to the O3 and whatever it is now, may be why. It's like watching the AlphaGo ELO curves. It just keeps going up and up and up and up. Remember, this is what we're seeing here on our side, right? Not the OpenAIers on the inside. This is just what's visible to us. What are they seeing? It's got to be much, much crazier than this. There may be a sense that they've broken out and have finally crossed the last threshold of criticality from merely cutting-edge AI work, which everyone else will participate in a few years, to take off, cracked intelligence to the point of being recursively self-improving, and where O4 or O5 will be able to automate AI R&D and finish off the rest. So this is the path of like the intelligence explosions that people like Aschenbrenner talked about. So his big point wasn't that we don't have to have AI automate everything in order for it to have a massive changing impact on every human being on the planet. Really, we only have to have it automate one thing and one thing only and be good at that. And that is AI research, right? So the research and development and improvement and optimization of AI itself. If it's recursively self-improving, that's it. Because then it will be able to figure out everything else. That's the only thing that we have to get it to do, and then everything else that's the first domino that just topples everything else. And so Altman in November 2024 saying, I can see a path where the work we are doing just keeps compounding and the rate of progress we've made over the last 3 years continues for the next 3 or 6 or 9 or whatever. And then just a week ago, Sam Altman saying we are now confident we know how to build AGI as we have traditionally understood it. We are beginning to turn our aim beyond that to superintelligence in the truest sense of the word. We love our current products, but we are here for the glorious future. With superintelligence, we can do anything else. Let DeepSeek chase their taillights. They can't get the big iron they need to compete once superintelligence research can pay for itself, quite literally. And that's probably why we're seeing all of these things coming out of the White House, restricting the export of chips to various countries, namely China, right? So DeepSeek is a Chinese model. So US and friends are really careful about where they allow these NVIDIA chips to sort of diffuse into, what parts of the world they're allowed to go into. And so he continues, and then you get to have your cake and eat it too. The final AlphaGo/0 model is not just superhuman, but very cheap to run too. Just searching out a few plies gets you to superhuman strength. Even the forward pass alone is around pro-human strength. If you look at the relevant scaling curves, may I yet again recommend reading Jones 2021? The reason for this becomes obvious. Inference times search is a stimulant drug that juices your score immediately, but asymptotes hard, meaning so there's like a wall it hits. There's only so far you can take it, right? So it's a big initial boost, But that alone isn't quite sustainable because like the cost is exponential. So you can get much better answers, much more intelligence, but like the cost is exponentially scaling. So for example, for the O3 models, how well they did on the ARC, just to give you an idea. So this score was, I think they spent something like, if they were to pay sort of retail cost for it, like what you and I would be paying for the compute, I think it was under 10,000. I don't remember if it was like 8,000 or 2,000. It was under 10,000 because it was within the ARC AGI kind of rule book. It was supposed to be under 10,000. The O3, the high that beat the human level benchmark and kind of like went above it, that was probably more like 300,000 plus, right? So it's much, much, much more expensive. Yes, it beat the ARC AGI, but it's prohibitively expensive to actually run for any sort of real use case scenarios. So he continues, quickly, you have to use a smarter model to improve the search itself instead of doing more. So instead of doing more search, you want to improve the model's ability to do search. If simply searching could work so well, chess would have been solved back in the 1960s. It's not hard to search more than the handful of positions a grandmaster human searches per second. If you want text which reads "Hello World," a bunch of monkeys on a typewriter may be cost effective. If you want the full text of Hamlet before all the protons decay, you'd better start cloning Shakespeare. Fortunately, you have the training data and model you need right at hand to create a smarter model. Here's the Sam Altman tweet saying O3 Mini will outperform O1 at a massive cost reduction. So it's interesting that you can spend money to improve the model performance in some outputs, but you may be the AI lab and you're simply spending that money to improve the model itself, not just a one-off output for some mundane problem. This means that outsiders may never see the intermediate models any more than Go players got to see random checkpoints from a third of the way through the AlphaZero training. And to the extent that it's true that deploying costs 1,000 times more than now, there is a reason to not deploy at all. Why bother wasting that compute on serving external customers when you can instead keep training and distill that back in and soon have a deployment cost of a superior model, which is only 100x, and then 10x, and then 1x, and then less than 1x. Yeah, and certainly we know that OpenAI it's not making money by providing these models, these services to the customers, right? So it's not kind of this cash flow business where it's trying to make a profit. In fact, I think a long time ago when they were just starting up, I think Sam Altman kind of jokingly said, this is probably around, ChatGPT, like right after it got released. He said, instead of trying to figure out what business model to kind of create to put AGI to use, why not just create AGI and ask it to come up with the business model? And this is what Ilya Sutskever is probably doing with his new company, SSI, Safe Superintelligence, right? As he says on his website, they're a straight shot to superintelligence. No intermediate products. Right, this is SSI.inc. They're saying superintelligence is within reach. They're going to have one goal and one product, a safe superintelligence. Our singular focus means no distractions by management overhead or product cycles. And our business model means safety, security, and progress are all insulated from the short-term commercial pressures. So again, more and more, it seems like they're saying like, we can't be bothered to release products to the users. We just need to like lock in and just keep scaling, keep improving until we get to superintelligence. Not only that, but it seems like that superintelligence is within reach, or at least there's a straight path to it. By the way, if you're one of the people that's invested in OpenAI, you have some sort of an equity, I would be willing to be adopted by you. Just saying, let's talk. So Gwern continues, thus, the search test time paradigm may wind up looking surprisingly familiar once all the second-order effects and new workflows are taken into account. It might be a good time to refresh your memories about AlphaZero/Mu0, training and deployment, and what computer Go/chess looked like afterwards as a forerunner. And Jones 2021, we'll take a look at that in a second, is more relevant than several of the references here, like Snell, because Snell is assuming static, fixed models and looking at average case performance rather than hardest case. Even though the hardest problems are also going to be the most economically valuable, there's little value to solving easy problems that other models already solve, even if you can solve them cheaper. In such a scenario, it is not surprising that spamming small, dumb, cheap models to solve easy problems can outperform a frozen large model. So again, the big Hive Queen model creates low drones that are very effective at doing that particular thing, that solving that particular problem. But that is not irrelevant to the long-term dynamics where you are training new models. This is a similar error to everyone was recently enthusiastic about how overtraining small models is compute optimal. True only under the obviously false assumption that you cannot distill, quantify, prune large models, but you can. So this is the paper Jones 2021 that he's referring to. So ELO or LO is kind of like how you determine how strong or weak an opponent is. So used across many games kind of to determine the relative strength of opponents, right? So you have experts on the high end, beginners on the low end, etc. So here you can see kind of the training curves for these self-play models. So whether they're playing Go or chess or Hex, whatever board game they're playing, the numbers here are the board size. So the bigger the board size, obviously, the more complicated it is. So 3x3 is the smallest interesting board size. 9x9, this was the largest board Mo Hex can achieve perfect play on. So the agents play against each other for 1,024 matches. And so if a 0 up here is perfect play, right? So as you can see here, the more sort of compute we give it, we throw at it. These are sort of like the variances of it, different sort of snapshots. There are different agents doing different plays with these. The big line, the thick line, that's like the best one, right? So the frontiers, the dark lines formed by taking a maximum across training runs. The point being is 3x3 is a very simple board. There's not a lot of complexity. So we need a little bit of compute and not that long, and it approaches perfect play. If it's 4x4, right, it doesn't start out as good, and we need more compute to get it to perfect play. And that is true for every single other one, right? So 9, in the beginning, it's god-awful, but again, we give it more and more compute, and it gets better, and it approaches perfect play. So in this scenario, in this sort of thing that they're testing, and obviously there's such a thing as, perfect, right? The perfect game. There's tons of things where there's probably not a perfect game. Like if you were trying to run a massive company, are there like the perfect ways to run it, like the best possible? Maybe, maybe not. But the point is, like, imagine training something that over time follows this curve to approach some potential perfect way of running a company, or doing scientific discovery, or managing a government, managing the traffic system, managing a hospital, just anything you can think of, right? If you're able to sort of figure out what you want it to do, in a hospital, cure sick people and make sure people don't die, make sure everybody's happy, and, try to not to waste resources, whatever sort of KPIs a hospital might have, and you tell it to improve that. So I think if we were kind of to really simplify this I would put it like this. We already know how to create super intelligent AI. We have the recipe for it, right? But it's a super intelligent narrow AI. It's only super intelligent, much better than humans at certain specific limited tasks. So here's Google DeepMind, kind of how they view the different levels of AGI, right? So from level 0, none, right? Or I guess different levels of AI, right? And so then we have emerging. So emerging AGI, then we have competent AGI, expert AGI, virtuoso AGI, and then superhuman, right? So an expert would be like in the 90th percentile of skilled adults, right? So in AlphaGo, it would be in the 90th percentile. Some people get percentile and percent confused. So 50% is like this half, this whole thing. That's 50% of the whole. A percentile is just like this sort of sliver. That's the 50th percentile. So if you are here, you're in the 50th percentile. If you're talking about from here up, that's 50% of the whole. Right, and virtuoso, it's at the 99th percentile of skilled adults, and then superhuman, it outperforms 100% of humans. So AlphaGo is a level 5 superhuman AI, but it's narrow, right? It has a clearly scoped task or set of tasks. That task is just absolutely smoke the best Go players in the world, right? But kind of like this thing that we're talking about is general, right? AI, kind of artificial AGI, artificial general intelligence. So it's generally able to do all those things. AGI would be sort of human level general intelligence, right? Or as Google DeepMind kind of break it down. So for example, emergent AGI, right? So it's equal to or somewhat better than an unskilled human. So do we have examples of an emerging AGI? Yes, ChatGPT, Bard, Llama, et cetera, et cetera, et cetera. This is a little bit outdated. There's probably going to be a lot more there. Competent general AI, right? So at the time of when they posted this, they said not yet achieved. I think since then, some people would argue that maybe we would have some examples, here of perhaps the O1 model, 3 model, and some people would argue for or against it. But I mean, if it's saying at least 50th percentile of skilled adults, I don't know. I feel like we could put the O1 there. Yeah, I think so. I did this poll asking all of you wonderful people, is AI smarter than the average human? 8,000 plus people put in their votes, and 67% of you said that yes, AI is now smarter than the average human. Now notice, like 11 just skipped the answer. So if you look at just the people that said yes and no, this would be more like 75%. So out of the people that answered, 75% said yes, it's smarter now than the average human. So I would argue then we'd have a placement here in the competent AGI. But the point being is that we do kind of have a recipe for building a superhuman AI in these narrow tasks. We have a recipe for it. Google DeepMind they cracked it, I feel like. And a lot of it has to do with that sort of like the reinforcement learning. There's self-play, like all these are kind of ingredients in making that happen. So here's Demi Sasabi's on 16 Minutes. This was a while ago, but he's saying if you program AI to play chess, so I think this was before a lot of people knew kind of what they were talking about. So the language here is a little bit off. So what they're saying is when you have the system like AlphaGo or any of the alpha models and it's engaging in self-play, right? So it's playing itself, creating games, learning, improving, et cetera, et cetera, et cetera. It might have billions of games that it runs through, right? And so Demi Sasabi, what he was explaining in this, I believe, I'm paraphrasing slightly, but he's saying sort of you start that process, right? If you start it in the morning and this AI is it doesn't know how to play chess. It's the worst, right? Right, it's here. Like it's god awful. It's worse than the worst player because it doesn't even know what it's doing, right? And then it continues. Then by lunch, it could beat most players, and by the evening, it's stronger than the world's champions. So he's kind of describing this curve here, right? It starts out not knowing what it's doing, and then it approaches, the sort of the optimal play, the perfect play. So we kind of know how to build this, but we couldn't do it for general tasks because we didn't know how to make it. Like you needed very specific outcomes. Like in chess, it's obvious what you want the model to do to win. And you can like, in very certain terms, tell it what it means to win. Like you can set certain metrics that you want it working towards. OpenAI back in the days had this little game where these little agents were trained to play hide and seek in a simulation. So it's kind of like a video game. And so when they started, they moved randomly. They didn't know what they were doing. Over time, the seekers learned to chase hiders. By the way, the reward function was very simple. If the seekers could visually look at the blue guys, the hiders, and there was a field of sight, it would get like +1 point. So it would be happy. It was like, yay, I'm doing the right thing. And vice versa for the blue guys. They're like, if they were hidden, these guys couldn't see them, there was no direct line of sight, they would get +1, So it wasn't even like winning or losing a game. It was like, could these guys, for extended periods of time, remain hidden? So we ran like 22 million simulations, like from zero, where they didn't know how to move. They just had no brains or any intelligence, right? By 22 million, seekers learn to chase hiders. So they're almost like at the level of babies where they're like, or toddlers, were like, oh, I want that thing. Let me move towards it, right? That's kind of like the level of abilities. By 88 million, hiders learn to construct a shelter to hide in, right? So we're seeing some almost not human level intelligence, but we're seeing some sort of intelligence here. Seekers learn to use ramps to jump over obstacles by 115 million of these games, right? And it continues. It gets kind of nuts, including where, some of these little AI agents found ways to exploit the physics engine in unintended ways. So the developers that built this world, they didn't know about certain bugs or exploits or whatever. They didn't, they needed to have like a patch to correct it. But these little AI agents figured out how to exploit those things. They found that if they picked up one of those ramps and they ran at the wall and they hit it at just the right angle, they can launch themselves in the air and then land where the hiders are. So they could catapult themselves. The developers obviously did not intend for this to be a thing. It was like a glitch. Remember Jason Wei, the researcher at OpenAI? This is recent. This is today. Magic is what happens when an unstoppable reinforcement learning optimization algorithm powered by sufficient compute meets an unhackable reinforcement learning environment. Right. What's funny is like one of the commenters are Jonathan Ivan, No Free Will 42 says, I hope it's a better design environment than, the multi-agent hide and seek. Have a like a good surf. Phenomenal. An underappreciated comment of the year, I think. How am I not following this guy? I got to follow Jason. Anyways, jokes aside, we were trying to figure out, I think, how to create these general AIs and have them hit this sort of the same curve. So we had a recipe for building super intelligent AI systems for Go, chess, etc., playing hide and seek, whatever. But that recipe didn't work for sort of general intelligence, for reasoning. It really seems like just recently, within the last year or however long, we've figured out how to take general reasoning and shove it in that recipe for creating superintelligence and make the curve go like that. And now that's what's happening. Here's Andre Karpathy saying magic is when the optimization hacks even that environment. So probably kind of referring to the same thing. I think he was one of the people on that hide and seek project. So I posted this video on my channel early 2023. So this must have been taken a few months after GPT-4 came out. So this is, of course, Andre Karpathy, one of the sort of early people at OpenAI. Listen to this. It's just like 10 or 20 seconds, and it really showcases where we were not that long ago and why this is kind of a big deal.
Early OpenAI, that's when it was like maybe a dozen people. And this was 2016 or so. And the zeitgeist of the day actually were RL agents. And so everyone's really interested in building agents, but very much at the time it was in the context of games primarily. So it was the height of excitement around Atari and all the game playing and so on. And so my project at OpenAI was trying to focus the RL agents not on games, like Montezuma's Revenge and so on, but on using computers, using keyboard and mouse. And so I wanted to make them useful, I wanted to make them do lots of tasks. And this project was called World of Bits. And I worked on it together with Tim Shee and Jim Fan. They're somewhere here, I think I saw them.
Jim Fan, so that's Dr. Jim Fan, senior AI researcher at NVIDIA, one and the same. They're best buddies. They work together on this project. Well, I don't know if they're best buddies, but they're certainly good friends.
And so the three of us ended up publishing a paper. It's not a super amazing paper, because basically at the time, all you had as a hammer was learning. And so we had these very simple web pages where we were trying to order a flight or order something to eat in very simple web pages. And we were mashing buttons and mouse clicks and so on, and we were trying to stumble our way into a higher words, and obviously it didn't work. So the technology was just not ready, and that was not the right thing to work on at the time. And so it turns out that the right thing to do at the time was actually to forget about AI agents altogether and start building language models. And then language models, now we're back here 5 years later. I got distracted with self-driving for a bit there.
So 5 years before this was recorded, they were trying to do reinforcement learning for agents to go online, book trips or whatever, and it was a dead end. You couldn't do this for, booking flights and clicking a mouse on the right things on screen, whatever. It wasn't there. There wasn't, you couldn't set up that environment. The goals weren't that easily understood, like with the hide and seek. It's like, do you see this guy? If yes, good job. If no, then bad job. It's super easy to explain. For navigating the web, not getting scammed, not doing silly things, you need that sort of kind of general intelligence. By the way, can I just please say this? So this is my video from over a year ago, November 24th, 2023. So it's a year and a few months, where we're literally talking about this, the same thing that's coming out now. It's the linking of large language model training and usage to the core components of deep reinforcement learning that enabled successes like AlphaGo, self-play, and look-ahead planning. Here's what we were talking about on this channel a year plus ago. Take a quick listen, just 5 seconds. And as self-play continues, this is saying that both its ability to make good moves and its ability to understand the board and who is more likely to win, both of those are improved iteratively. As the policy gets better at selecting moves, there's more data to learn from, and it provides better feedback to the policy, to the AI. So that completes an ingenious perpetual motion machine. By the way, I mean, this is when people talk about AI safety, when they talk about the various threats that AI poses. I mean, this is where I think most people need to understand. This is where it gets a little bit scary. This perpetual motion machine. But because the motion in this case is the AI getting smarter. So it's perpetually getting smarter, and better at getting smarter, doing that recursively and doing that, faster and faster. At the time, a lot of people thought I was nuts. I thought people were saying this is a conspiracy theory. I should stop spreading misinformation. I should not talk about this or that or whatever. Around the same time, we were also talking about using GPT-4 in teaching other models of knowledge distillation, of creating synthetic data to train the future models in. That was November 25th, 2023. If you've been watching this channel since then, a lot of this shouldn't come as a surprise to you. We kind of knew where things were heading. Now, we didn't know how well it's going to work, how fast. Certainly does seem like things are moving faster than we anticipated. But literally the idea of large language models joining kind of the ideas behind AlphaGo and all those models to put together to then unlock that next stage of evolution, potentially getting us to, I don't think I used the word superintelligence at the time, but we were saying it's certainly going to like bootstrap itself to higher intelligence levels, recursive self-improvement, etc. But what does this all mean? It means that we're probably approaching the singularity, some sort of a rapid improvement in intelligence, the intelligence explosion, potentially the automation of AI research. Alec Radford is often sort of credited as one of the, maybe not the smartest, but certainly one of the smartest sort of AI researchers of especially the recent decade or so. I don't know too much about him. He's very much like in the background, but Sam Altman is saying, I believe he's a genius at the level of Einstein. And so like one of the ideas in Aschenbrenner's paper is like what happens when AIs are able to do AI research at the level of somebody like Alec Radford. And instead of one, you can have 1,000, 1,000,000, 10 million, right? An infinite amount of sort of clones working 24 hours a day. And each time one learns something, all of them learn that thing. And each time they improve something, they are also themselves sort of improved. So whatever happens next, buckle in, make sure you're subscribed because you're going to know what's happening a year before everybody else is. And before you go, let me know in the comments what you thought about this. Are we about to take the reasoning abilities of these large language models and finally we figured out how to create that RL, reinforcement learning sort of algorithm, the space for them to just get smarter and, just like the hide and seek players or the Go players play billions of games against themselves to improve themselves very, very rapidly. Did we create that environment for words, for reasoning, for large language models to, self-play and keep bootstrapping themselves into higher intelligence levels? Are we about to see this kind of like reasoning of their ability to think through things and make the right decisions? Are we about to see the ELO rating of that go from okay, one is smarter than, or at least it's better at answering certain questions than PhD level people, than a lot of the best and brightest at math, right? So what happens if it just like keeps improving and starts approaching that sort of perfect play, optimal play? Or if there's not such a thing, at least something resembling that, like what does that even look like? What impact does that have in the world? Like if you're alive right now, number one, don't die. Just don't die right now. This would be a very bad time to die. And number two, just take a second to understand that this has got to be the most exciting period in human history, maybe ever. And we're witnessing it live. With that said, my name is Wes Roth. Thank you so much for watching, and I'll see you next time.